All right. This is Algebra 2, Lecture 830, 831, and 91. OAS 82821, the student will factor quadratic trinomials, similar to what we've been doing in the past. But in this case, we're going to factor quadratic trinomials in which the terms share a common factor. I want to point out this will be 3 days. On 9-1 will be the last of these assignments. 9-2 will be Thursday. We'll have a review. And then on 9-3, Friday, we're going to have our first test. So here we go. Today we're going to learn how to factor quadratic trinomials in which the terms share a common factor. The general form of a quadratic trinomial is ax squared plus bx plus c. It can be written that way, where a, b, and c are some real numbers. If we look at a quadratic trinomial and we're trying to factor it, and a is not 1, everything we've factored so far, the leading coefficient, that's the coefficient of the quadratic term, has been a 1. So we need to know how to factor it if it's not a 1. So if a is not 1, we check to see if each term is divisible by a. And if it is, we're going to factor out the common factor. If every one of these is divisible by a, we'll factor it out and then factor the remaining quadratic trinomial. Okay, and I'm going to show you what that looks like. Here we go. Factor completely. I look up here and I say, hey, this leading coefficient is not a 1, so I've got to do something. And up above it says check to see if this is a factor of every single term. And it is. 2 will divide in evenly into each one of these terms, so it's a factor of every term, so we're going to factor it out. Factoring it out is just a matter of writing down the factor that all of the terms have in common, opening up a set of parentheses, and then writing each of these terms after that term has been pulled out using division. You're going to divide in your head each one of these numbers by 2. So if I divide this by 2, it turns into 1. 1 times x squared is x squared. If I divide this by 2, don't forget to bring your plus sign down. If I divide this by 2, it turns into 1, and 1 times x is x. And if I divide this by 2, it turns into -6. Now I've got a quadratic trinomial that's very similar to what we've factored in the past. I'm not going to get rid of this 2, it's going to stay there, but I'm going to factor this the way we've been factoring all the other ones. I'm going to bring this down, bring the 2 down, and open up 2 sets of parentheses, because now this has got a 1 as a coefficient. We factored out the 2, so this is a 1, and this is also a 1. You can put a 1 here if you want to. It's implied, it's understood. What we're going to do now is take the square root of this one, put it here and here. Take factors of 6, that's numbers that we can multiply together to give me 6, that will either add or subtract to give me 1. Okay? And those factors would be 3 and 2. Doesn't matter where I put the 3 and the 2. I can put the 3 here and the 2 here. What matters is they have to add up to +1. And the only way that can happen is if the 3 is positive and the 2 is negative. And once we get that done, we have successfully factored this quadratic trinomial in which the leading coefficient is not a 1. We did that by factoring out the leading coefficient. We saw that it was a factor of every term. We factored it out, and then we factored the remaining quadratic trinomial. Hopefully, I did that correctly. This could be written, if you're taking a multiple choice quiz or test or worksheet, the order of the factors doesn't matter. Whoops. That's supposed to be a minus sign. You put the factors in any order. This could come here and this could be here. So both of these are correct. Okay? And now I'm going to check to see if I got it right. Got my handy dandy answer key right here. 2 times the quantity x minus 2 times the quantity x plus 3. So yeah, it was written this way on this answer sheet. Alrighty, let's take a look at another one. going to scooch this stuff over just a little bit. Give myself a little room. I look up here and I'm just going to try to factor this, and I always check to make sure that this is a 1. If it's not a 1, then I have to deal with it. And now we have a tool to deal with it. I'm going to check to see, since this is a 6, I'm going to try to factor a 6 out of every one of these terms. So if I pull a 6 out of this one, it leaves me with a squared. I'm dividing each term by 6, 1a squared. If I pull a 6 out of this one by dividing, 66 divided by 6 is 11a, plus pulling a 6 out of that by dividing gives me 1/8, I believe. 18 times 6. Yes, that's correct. All right, so now I pulled a 6 out of every one of these. When I go to factor this quadratic trinomial, this is now inside this set of parentheses, this quantity. This now has a coefficient, a leading coefficient of 1, so we can factor it using the same techniques we've been using. I can't forget this though, this has to come down. This comes down and I open up 2 sets of parentheses to factor this. And we factor it just like we factored everything for the last couple of days. I take the square root of this one and I put it here because now the leading coefficient is a 1. I factored out the 6. I look for factors of 18. That's numbers that you can multiply together to give you 18. And those same numbers will add up to 11. And those numbers would be 9 and 2. Doesn't matter where I put the 9 or the 2. Could put the 2 here and the 9 here. What matters is they have to add up to -11. And the only way that could happen is if they're both negative. -9 plus -2 is -11. So if I haven't made any mistakes, I've successfully factored this quadratic trinomial in which the leading coefficient was not a 1, but rather a 6. And we took care of that by factoring out the 6 and then factoring the remaining quadratic trinomial using the factoring techniques we've already learned. So this could be our answer, or it might show up looking like this. The order of the factors does not matter. Okay. So hopefully I got that one right. Let's take a look at the answer key. 6 times the quantity a minus 2 times the quantity a minus 9. Yay, they wrote it like that. Okay, I think you guys are getting the idea here. Let's take a look at one more. This is 4m cubed. We didn't talk about this, but you might see it. So note the m cubed. What I see here is my leading coefficient is a 4, and I see that every single term has an m. Up here, every single term didn't have an x. This one didn't have an x. Highest power was a 2. I'm going to turn this into a 2 by factoring out an m out of every single term and this 4. I'm going to factor out the leading coefficient and this extra m that's been thrown in there. So it's going to look like this. I say, hey, each one of these has a 4 in it, is divisible by 4, and they have an extra m. It's not quadratic. It's raised to the 3rd power, but we can pull an m out of every single term. So I'm just going to write it down, open up a parenthesis, and then write what's left. If I pull a 4 and an m out of this, I'm just left with m to the 2nd power. I'm dividing this in my head. If I divide that by 4, it turns into 1. If I divide that by m, it turns into m squared, m to the 2nd power. And you can check to see if that's correct. Just multiply these two together and you should get 4 times m times m times m. That's 4m to the 3rd. If I pull a 4 out of this, I get a 10. If I pull an m out of that, whoops. If I pull an m out of this, that leaves the other m, because I pulled a 4 and an m out. And now I'm going to pull a 4 out of this, and that leaves me with 1. Well, got a plus on there. If I pull a 4 out of this, dividing it by 4 leaves me with 1, 4. Is that right? And I pull an m out, and that leaves me with 1. 14 times 1 is 14. My brain went blank. I want to make sure I divided that correctly. Getting old. Can't divide 96 by 4. 96 divided by 4 equals 24. Mercy. Told you I was getting old. But it's early in the morning. I gotta cut myself some slack. It's ridiculously early. Okay, so I factored a 4 and an m out of each term. When I pulled a 4 and an m out of this, I was left with m squared. If I pull a 4 and an m out of this, I'm left with negative 10 m. If I pull a 4 and an m out of this, I'm left with 24. The m is, and to check to see if you've done it correctly, you can just multiply this in your head and see if you get these three terms. 4m times m squared is 4m cubed. 4m times negative 10m is negative 40m squared. M times m is m squared. And 4m times 24 is 96m. So I pulled the common factor out. Now I'm going to factor this remaining trinomial. 4m. Square root of this one, this is now a 1 because I factored out the 4. The leading coefficient inside this set of parentheses is a 1. So I'm going to put the square root of this one here and here. I want factors of 24 that will add up to 10. There are two possibilities. 2 times 12 will work, and 6 times 4. So one of those will work, one of them won't work. So let's see which one will. Let's try 6 and 4. 6 times 4 is 24, 6 plus 4 is 10. The only way that can work is if these will add up to negative 10 if they're both negative. Now we're going to check, we're going to use our test. I'm going to see if these two numbers will multiply together to give me 24 and add together to give me negative 10. Negative 6 times negative 4 is positive 24. Negative 6 plus negative 4 is negative 10. So this is the correct answer. But let's for just a second say that we had tried 2 times 12. Let's say we had said, well, 12 and 2 are factors of 24. They'll multiply together to give me 24, and they'll add up to 10. So we say, well, we're going to put the 12, doesn't matter where we put the 12 and the 2. What matters is they add up to negative 10. So the 12's got to be negative, the 2's got to be positive. And now we do our check. Is negative 12 times positive 2 negative 24? Nope. So we would know that this is not the case. And we would look for other numbers that add up to, or that multiply together and add up to 10. Multiply it together and give me 24 and add up to 10. And hopefully we would come up with 6 and 4. And again, it doesn't matter where we put the 6 and the 4. What matters is they add up to negative 10. And then our check is negative 6 times negative 4 is positive 24. And we already checked that. We knew it would work. But there we go. So this will be our answer. And remember, the order of the factors doesn't matter. Could be m minus 4 times the quantity m minus 6. And there we are. So if you have m to the third power, pull your common factor, the coefficient of the biggest term, the biggest variable term, out and a variable with it. And then rewrite it, and you'll have a quadratic trinomial if each one has that term. And go ahead and try to factor that. You can do this.